Hello and welcome back to 5-Minute Chemistry. Today we are going to be talking about a few interesting questions about elements and atoms. So let's refresh our memory on what elements and atoms are. So an element is an inherently chemical concept. It was developed based on the behavior of materials in chemical reactions, and elements were the chemical materials which could not be decomposed into different materials. But after understanding how atoms worked, the concept of elements got redefined based on the number of protons in its atoms. But the element is a conceptual category, so you can divide the atoms you have into elements, but element also is used as a type of pure material. So if you have a material that can either be a mixture or a pure material, in a pure material you have a fixed composition, and if it's a fixed composition of different atoms, then it's a compound. If it's the same atoms, then it's an element. And the atoms, on the other hand, are the specific particles that actually exist in reality. So atoms can be categorized by their characteristics, and one of their characteristics is the number of protons, which we can use to categorize them as elements. But there are also other ways, so you can categorize them by mass number, for example, or neutron number also. One of the things that we avoided talking about until now is allotropes. So we know that elements are made up of the same type of atoms, but some of the elements can have different forms. So graphite and diamond are actually pure carbon. Both of these forms of carbon are made up of only carbon atoms. The difference is how these carbon atoms are bound together. The other well-known example here is for oxygen, which is in a diatomic form in air, but we also have ozone, which has 3 oxygen atoms in one molecule. So both of these are gases. So you can have a mixture of the different forms of same elements, which would only contain one type of atom. So if you have a very, 18th century way of looking at it, you might be confused by the fact that a mixture of oxygen and ozone is only made up of one type of atom, but it's actually still a mixture because both oxygen and ozone, they're separate chemicals, so both the oxygen and both ozone has its own distinct properties. And so if you mix the two together, it is going to be a mixture because you can mix these two well-defined materials in a kind of arbitrary ratio. Okay, so let's go into some more weird things. Element 0. So now that we redefined elements based on the number of protons in the atom, what happens when we don't have any protons in an atom? So this is called something like neutronium. There is no proton, only neutrons. We know that there are neutron stars, but neutron stars, actually, they are bound together by the gravity. So this is a very massive object, so there is very high gravity that bonds it together. Nucleus of an atom is actually bound together by the strong force and the weak force, so nuclear forces. So that is kind of different there. And because if you have a neutronium, which is only made up of neutrons, there is no proton. So if there is no proton, there is also no electron. And if there is no electron, you don't have any chemistry. So this is why I wouldn't consider, and most people wouldn't consider, neutronium or just lone neutrons as an element by itself, an element 0. The fact that lone neutron is an unstable particle and the multi-neutrons like 2, 3, 4 neutrons bound together were not really observed in reality, that isn't really the disqualifying factor here. The biggest disqualifying factor, I think, is that there is no chemistry if you don't have electrons. There are also some exotic atoms which are made up of different particles, not protons, neutrons, and electrons. So some of the subatomic particles are changed. So muonic hydrogen has a proton which is orbited by a negative muon. So negative muon has the same negative charge as an electron, but somewhat heavier, but this is also not really a stable particle. And we also have muonium, which is the opposite. We have a positive muon, which is same charge as a proton, but much lighter, and it is orbited by an electron. And the most widely known exotic atom which exists is the positronium, which is composed of an electron and a positron. So positron is the antiparticle of electron. So if the two meet, they annihilate each other and create photons. So this is also not a long-lived thing, but positronium actually has chemistry, if you believe it. So you can have two positroniums which will combine into a dipositronium molecule, which is similar to like a hydrogen molecule, for example. And we also have positronium hydride, in which a positronium is bound to a hydrogen. So positronium is actually something that lives only on the nanosecond scale because of the annihilation of the two particles it is made up of, but still it has chemistry, so someone might even consider it an element, but it does not have any protons. So what do you do with that? What is the going to be your atomic number for positronium? So in general, no chemist would consider these elements because these are not real atoms. These are exotic atoms. These are particles that are similar to atoms, but they are not atoms by the strict definition. So based on that, we can exclude them from the definition of elements. Okay, so this is it for today, and I will see you tomorrow.